Hello everyone, myself Yadagiri, Assistant Professor, Department of EEE, MLR Institute of Technology, Hyderabad, and I'm also the Faculty of Basic Electrical Engineering. In the last session, we have discussed about the delta and star connected three-phase AC circuits. In that, we have derived the relationship between the line voltage and phase voltage, and also the line current and phase currents of the balanced delta connected system, and also the balanced star connected system. So in this session, we are going to discuss about the problems based on the delta and star balanced networks. So this is in that case the problem number one. So the problem number one. So a balanced star connected network of the impedance should be 8 plus J6 ohms per phase, and which would like to take the power supply should be 230 volts, 50 hertz supply. So based on this one, need to find the line current and the power factor of the system. Power factor of the circuit. So for that, need to go with the solution. Then in that, so before going to find the solution, then need to write the given data of the question. So given data we would like to write. So because every numerical kind of question, we need to go through the given data first of all. So for that, a line voltage mentioned, that is a VL equal to line voltage VL equal to 230 volts they have given. So then the supply frequency also mentioned as, that is a 50 cycles per second, that is C slashes means 50 cycles per second. One cycle for a second is nothing but 1 hertz means, so it is a 50 hertz. So the frequency should be 50 hertz. Then also the impedance value of the network is given as 8 plus J6 ohm, Z equal to, it's R plus Jx. So similarly, so they have mentioned that 8 plus J6 ohms. So if you are able to get the magnitude of the impedance of the network, that is a Z equal to, it is a square root of 8 square plus then 6 square. So we will get, that is a based on that we will get it as it's a square root of 100, then which will be Z equal to 10 ohms. So from this one, R equal to 8 ohms and X equal to 6 ohms. So this is the impedance of the network. So a balanced star connected load of 8 plus J6 ohms is connected to a 3-phase 230 volts 50 hertz supply. Find the line current and power factor of the network. So based further we need to go through the given data. So the given data is this one. Then Z equal to, we got it as 10 ohms. So then based on this data we need to find the line current and also the power factor of the system. So before going to find the line current, we would like to get the phase voltage value. So this is the line voltage, then the phase voltage value is, so we have already derived the relationship between the line and phase voltage of this balanced star connected network. So for that, VPH equal to the, it's a VL upon root 3. VPH equal to the VL upon root 3. So that VL value is mentioned, that is VL is 230. So divide by root 3. Then VL we got it as 132 because I have the answer. So for that 132.79 volts. So this is the it's a V phase value, phase voltage value. So V phase equal to the 132.79 volts. So, but it's not our aim to get that 132.79 volts. So we need to get the line current value. So determination of the line current, first we would like to get the phase current. Why? Because the impedance also mentioned in terms of per phase. That's why we need to get the I phase value. That is the I phase equals to the, that is a V phase upon Z phase. This is the formula. So I phase equal to the V phase, we will get it as we already got that, that is 132.79 volts upon 10. So after the simplification of this, we will get the line value as a 13.28 ampere. So this is the phase voltage, phase current value of the above network. So in case of the balanced star connected load or the source, the line and phase voltage, the line and phase currents must be same. So for that, the line current equal to the phase current. So based on the question number 1 is asked, that is line current. So the line current of the network, the line current IL equal to the, that is I phase equals to the, that is a 13.28 ampere. 13.28 ampere. So this is the first question answer. So till now we have discussed about the first of all line voltage value. Then after that, so phase voltage, line voltage given in the question. Then we need to find the based on that the phase voltage. Then after that we got the I phase value. Then based on that we will get the line current value. So in a balanced to star connected network, the line and phase currents are must be same. Both are same. Both are equal. So for that IL and I phase equal to 13.28 ampere we got. So this is only the first first answer, that is a line current value. Then after we need to find the power factor of the network. So the question number 2, that is power factor of the network. So the power factor is a cos phi. Notation is the cos phi equal to, that is a R by Z. Power factor equal to power factor is the notation is a cos phi. Then that value is R by Z. So we already know the value of R is a 6 ohms. I thought it is a 6 ohm. It is a 8 ohms. R is a 8 ohms according to the question. Then X value is a 6 ohms. Then need to substitute, and also we got the Z value based on this. Z is a 10 ohms per phase it is. Then the cos phi equal to, then it is a 8 upon 10. So then based on that the cos phi value equal to the, that is a 0.8. 8 upon 10 means it is a 0.8. Then the power factor of the network, then the power factor of the network, that is a cos phi equal to, so 0.8 lagging. It is a 0.8 lagging. So this is the end of the problem, end of the first problem. So in the first problem we have discussed, we have calculated about the line current value and also the power factor. So we are able to, before going to get the line current, we have determined the phase current value. So that we will get based under the help of VPH. Then after the VPH value we got, then we will substitute the VPH into the IPH formula. Then we will get the current in phase, and current in each phase we got. So in a star connected balanced network, the line and phase currents are both equal. So for that IL and IPH equal to 13.2. Then after the second question is in the first problem, that is the power factor of the network. The power factor should be cos pi equal to ratio of the resistance to impedance. Based on that we got that value as a cos pi equal to 0.8. So this is the end of the whole first question. Next we will go to the question number 2. 3 coils of each resistance is 10 ohm. 3 coils of each resistance should be 10 ohms. Then after that 10 ohms, and inductance of the coil is a 30 millihenry, which are connected in star across the 400 volts, 3 phase 50 hertz supply. We need to find, calculate the current drawn by the each line and also the power factor of the system, and as well as the total power taken by the whole network. So these 3 questions we need to find from this one. So 3 coils of each resistance. Before going to get the solution of this network, we need to go through the given data. So this is what the given data, that is a given data is a R equal to 10 ohms given, and then L of the inductance of the coil is a 30 millihenry, and so it would like to take the 400 volts voltage from the 3 phase AC supply. So the supply frequency is given as 50 hertz, and the line voltage given, if not mentioned means obviously line voltage only, that is a 400 volts. So based on this data we would like to get the line current to, then after that the power factor and also the total power of the network. So for that we need to find the first of all the value of phase voltage based on this one, because that is only the known, otherwise we can't get the remaining things. So that V phase equals to the, we know that given as a star only, that's why so V phase equal to VL upon root 3. Why? Because if it is a delta connected network, the phase one line voltage are same only, both are equal. So that's what they have given like a star. Based on that we need to get the V phase equal to the VL upon root 3. So if it is a delta, then VL and V phase are both are same, but they have given the question in the delta star network, that's why V phase equal to VL upon root 3 we have to consider. So that is a VL upon root 3. Then we need to get the V phase value is V phase equals to, so 400 upon the root 3. So I have the value with me, that is a V phase value should be equal to the, so it's a 231 volts. So this is a phase voltage value. So with the help of the inductance of the coil, we would like to get the XL of the network, that is XL value. XL equal to the, So that is a 2 phi times of FL. So it also say omega L, I mean x suffix L both are same. So which value is the 2 pi FL. So based on this one, we need to get the XL value. XL equal to, so 25 into and 50 into, it is a 350 into, then so 30 into 10 power minus 3. So therefore XL should be equal to the, that is after simplification of these all things, we will get the 9.42 ohms. So this is the XL value. So then after that we need to find Z phase value, because R and XL we got. Then based on this we need to find the, so impedance per phase value, because all are given in per phase only, because each phase mentioned like, so that Z phase equals to the, it is a R plus JX. So based on this formula, then 10 plus, so 9.42. So need to find the per phase impedance in terms of magnitude, so that we will get the, so 10 square plus 9.42 whole square. 10 square plus 9.42 whole square. So then need to get the Z per phase value. So Z per phase equal to the, we got that value as 13.78 ohms. So after simplification of this one, we got that 13.78 ohms, the impedance of the network per phase. So using this all things, we need to get the which value, that is the I phase value, because we got the V phase and also the Z phase. Based on this, we'll get the, so question number 1. So that is, it's not a question number 1, it's a indirectly question number 1, because I phase and as well as I lines are same in case of star connected network. Star connected balanced network. Star connected balanced network. The line and phase quantities are equal. So for this, the formula is I phase equals to the, it is a V phase upon Z phase. V phase upon Z phase. After substituting these values, we will get the line and phase currents. That is a I phase equals to the, I phase equals to the V phase, rewriting the same thing only, Z phase, which means 231 divided by the, so 13.732, 73 or 738. So 13.738 means 74. So then current per phase in each and every phase should be equal to the 16.81 ampere. So in a star connected balanced network, the line and phase currents are equal. That is IL equal to the, then I phase equals to the 16.81 ampere we got. So this is the end of the first question. So then we need to find based on this one, that is question number 2, that is power factor. Power factor of the network. So power factor. The notation of the power factor is a cos phi. So cos phi equal to R by Z. Cos phi equal to R by Z. This is the formula. So R value we already know that, because it was mentioned in the question. So therefore cos phi equal to R is I think R value is 10 ohms. Then divide by Z is, we got it as 13.738 ohms. Then the power factor of the network, cos phi equal to, then after simplification of this one, we got it as 0.72, 0.72 lagging again. So the end of the question is power factor of the, so network, power factor of the star connected balanced network is a cos phi equal to, that is a 0.72. This is the end of the question number 2 in the given question. Next, need to find the question number 3. The question number 3 is a total power. Total power. So before going to get the total power, we need to get the power in each phase. And also we have derived the formula for power in each phase. That should be so power in case of 3 phase equals to the, so root 3 times of VL, then IL, then after that cos phi L. VL, then cos phi L. So this is a formula we have already derived in each and every network. That is so balanced to star connected network also we have done, and the balanced to delta connected network also we have done. We got both networks are given the same equation. I mean power in case of 3 phase balanced to delta or star connected network, that should be root 3 times of VL IL cos phi L. Then need to substitute these all values. Power in case of 3 phase equals to the, so root 3 times of I think it was a 400 into then 16.81 is a line current into 0.72. So then after simplification of this one, we got the answer as power in three-phase network. I mean the total power of the network should be, so it is a 84 then 78.5 kilowatts. 5878 kilo 0.5, I mean 8478.5, so kilowatts power taken by the network. I mean the total power has to consume the network should be this one. So this is the end of the third question. So asked about the line current, then also the power factor, and as well as the total power consumed by the network. So this is the end of the second question. So we have discussed about the IL value procedure, plus the power factor, and also the power in entire system and power in entire network. That is the total power taken by the entire network. So now the summary of the session means, and also the summary of the module means. So we have to till now discuss it regarding the problems. Regarding this session I'm talking about. So till now we have discussed it in the first problem. We need to get the line current value and also the phase current value, and after that we have to we have determined the power factor of the network, that is a cos pi. Also we have got that cos pi equal to R by Z. So in case of the in case of the star connected balanced network, both line and phase currents are equal. Both line and phase currents are equal. That is IL equal to I phase. So in case of the balanced delta current network, that is a IL equal to it is a root 3 times of the I phase. It's also derived in the last module, last session. So then the power factor of the any system or any network, that is a cos phi equal to ratio of the resistance to impedance. So it was also, so we have discussed it in the first problem. So in the question number 2, we have discussed it about the phase and line currents. So phase and line currents in case of the star connected system. So in case of this one, we will get that IPH equal to the IL. So then in case of the star connected balanced network, then the line voltage is not same as the phase voltage, that is the root 3 times of the phase voltage. So from this one, phase voltage should be equal to it's a VL upon root 3. So this one we got, this one we have derived in the last session. So based on this formulas, we have also calculated the line and phase voltage and also the phase and line current. So then after that also we have discussed it in this module or in this session, sorry, that is cos phi equal to R by Z we got. So that is the power factor of the balanced star connected network also we got. So that is based on the values we got like a 0.78 like that, 0.78 lagging. Then after that also we have discussed it in the same session, that is in the problem number 2, that is the total power taken by the network. If it is a balanced star connected network, the total power is three phase power should be 2-3 times of VL then IL cos phi L. So if it is a network under the part of the delta connected, then we got the three phase power value should be same only. So in a balanced delta or star connected network, the three phase or total power taken by the network should be same only. So both networks are going to take same amount of power. If it is source going to deliver, so if it is a load, then we would like to apply, then that would like to consume. That's a root 3 times of VL IL cos phi L. So this is the end of the whole module. So in the next module, we would like to discuss about the module or unit number, that is AC machine, that is under the part of AC machine, that is a single phase transformers. So thank you and all. Thanks for watching the session.